So here we go. If you look at this slide, let's first talk about what they have in common. So if you look at this slide and you see a couple of pictures here, let's talk about what they have in common. All animals?
Yeah, also tails. Yeah.
Okay, so they all have tails, or they're all animals? Okay. What
Take it from the park.
do these have? Oh, okay, they all fly. Whoa! A map in there for you. What do they have in common? They both have a Y, right? They have in common a Y. What do they have in common? 11. Can I take an 11 out of both of those? And 1x. Okay? This is kind of leading us into what we're going to do today. We're going to talk about GCF. What do they have in common? What can we take out of all of them? All right, what do they have in common? Say it louder. They're all princesses. They're all princesses. That's me. All right. GCF is what we're going to talk about today, greatest common factor. Okay? So one of the things we're going to talk about is if every term has the same stuff, something in common, you can take it out, you can factor it out, and call the greatest common factor. Okay? Anytime I ask you to factor or solve by factoring, you should be following these 6 steps every single time. We will literally do this every single day for the next week and a half. Talk about these 6 steps. I will make you write these down every single day. So please make sure that you know these 6 steps. Just like the all night my aunt ran mail downstairs. If it helps you write the 6 steps down on your paper, on your test, on your homework, then please do that. Okay? You should be following the same 6 steps every single time I ask you to factor. Okay? The first step, anytime I ask you to factor, is I need you to take your problem and I need you to write it in order. What I mean by in order is that all of your stuff should be to the same side of your equal to sign. Everything should be together. And then it should be in order, your highest exponent down to your lowest exponent. Okay? Make sure that it's in order. Your second step always is to look for a GCF. Is there something that they have in common? Can you take out a number from all of them, or a letter, a variable from all of them, okay? A GCF. The next thing we're going to look at is to see how many terms each of them has. If your problem has 2 terms in it, just 2 little parts, then what you're going to do is you're going to factor either by squares or cubes. And we'll talk about those later next week. But if there are 2 pieces in your problem, 2 terms, then you're going to try to either factor by squares or by cubes. Okay? The next 2 steps happen if you have 3 terms in your problem. If there are 3 different terms, 3 different pieces, then you're going to factor one of these 2 ways. The first way is by basic factor. If it's not a basic factor problem, then it's a bottoms up. Okay? If you have 2 terms, if you have 3 terms, if you have more than 3 terms, so let's say 4 terms, then the way that we're going to factor is called grouping. Okay? We're going to do GCF today, and we're going to do grouping today. Okay? We're always going to look for a GCF first, no matter what. We'll talk about that today. And then we're going to talk about what happens if my problem has lots of terms in it, and we're going to factor by grouping. You ready? All right, let's talk about GCF. Okay? If you look at number 1, first thing I want to do, step number 1 is what? Put it in order. Right now, is this problem in order? No. So let's rewrite it so that the highest exponent goes first. So I'm going to take this 12x cubed, and I'm going to write it first. I'm going to take my 9x squared and write it last. This will help when we start doing more complicated factoring, always putting it in order. Okay? My second step is to look for a GCF, a greatest common factor. Is there a number that I can take out of 12 and 9? 3? Is there a higher number? Higher number than 3? Just 3, okay?
No, 3x squared.
I know, that's just little baby steps.
Don't forget
Three.
Don't forget the square.
I'll go get to it, Tim. 3. All right, now let's look at the x's. How many x's in the first thing? 3. How many x's are in the second thing? 2. What's the most I can take out of everybody? 2. An x?
Square.
Yeah! All right. I'm going to leave my leftovers. I took out a 3, and I took out an x squared from everybody. Now I've got to figure out what's left over. Okay? If I took out a 3 from this first piece, what's 12 divided by 3? 4. I have a 4 left over. I started with 3 x's. I took a squared out, Tim. So how many x's are left? 1. Plus, I started with 9. I divide by 3. I have 3 left. How many x's do I have left? That would be my factored version. I took out as much as I could. I've left my leftovers. Good? Okay. Let's get harder. First step. Is it in order? Kind of hard to tell, right? Bunch of different letters, bunch of different exponents. Sometimes it's a little bit harder to tell if it's in order because they're not all the same. If it's hard to tell, then you can go ahead and leave it like it is. Okay? What's my second step?
GCF.
GCF. Numbers. Numbers only. 24, 18, and 6. The highest amount that can be taken out of all those is 6. 6 goes into 24. 6 goes into 18. And 6 goes into 6. Let's take out a 6 then. I'm going to take out a 6 from everybody. Now let's do m's. How many m's are in the first thing? 3. How many m's are in the second thing? 2. How many m's are in the last thing? 4. What's the biggest amount I can take out of everybody?
2.
Let's take out an m.
Oh, m squared. I thought you could only take out 1.
This guy has 3. This guy has 2. And this guy has 4. So let's take out the most possible.
2. That's a 2, coach.
Thank you. Let's do ends now.
1.
I have 2 in the first guy. And 1 in the second term. And I have 3 in the last term. What's the most amount I can take out of everybody?
1.
Just 1? Because this guy only has 1 in it. Let's leave our leftovers. Ready? 24 divided by 6. 4. I started with 3 m's. I took 2 away. How many m's are left? Yes? I started with 2 n's. I took 1 away. How many n's are left? 1. Minus 3. Any m's? Any n's? Because I took all of them out. Plus. How many m's?
2.
2. How many n's?
2.
2. That is my factor form. Nothing else I can take out. Nothing else I can factor. That's it. All right, let's look at C. C looks a little bit different, right? Look at C carefully. Is it in order? I don't know. I can't tell if it's in order. That's what's going on. I don't necessarily want FOIL because foiling is the opposite of factoring. I don't want to FOIL. I want to factor. I want to break things up into small pieces, not make a big piece. Okay? So I don't necessarily want to FOIL. I want to factor. So if you look really carefully at C, do you notice anything?
There's an x, 2x minus 5.
This guy, doesn't he have an x minus 5? Doesn't this guy have an x minus 5?
Yeah.
So can I GCF out an x minus 5? Since they both have one in there? This guy has an x minus 5, and this guy has an x minus 5. So can I take 1 out? Just like I can take an x out of everybody, or an m squared out of everybody, I can take an x minus 5 out of everybody. They all have it in there. Let's leave our leftovers. If I took an x minus 5 out of this guy, what's left over?
X plus 6.
X plus 6. There's a plus sign in between, so I'm going to bring that plus sign down. Plus sign in between, I'm going to bring that plus sign down. I also took out an x minus 5 from this piece. What's left over here then?
2x plus 5.
2x plus 5. All my leftovers are in one parenthesis. Notice anything else?
There's 2x's.
What do you mean?
There's an x at the beginning and 2x.
You're looking in here?
Yeah.
Or would you leave it like that?
No.
What can I do with all that stuff?
Combine.
Can I combine that? What you mean by 2x's? Put the x's together? I have a 1x plus a 2x. Can I really say 3x plus this is nice little factored pieces. Not foiled, factored. Okay? So if you notice that they all have the same stuff in it, or something that's the same, take it out and then leave your leftovers. In your leftovers, can you combine like terms? Now look at your leftovers. Is there anything I can take out of my leftovers? A GCF inside here? Any GCF inside here? So it looks like it's as factored as possible. All my little pieces are as factored and broke down as possible. You're okay with that one? Okay, we're going to kind of do the same thing when we start doing grouping. Let's do this one. Let's do D. Look at D. I do not foil, right? That's going to give me opposite of what I want. I want to factor. Look at D really carefully. Do you notice anything?
You get the factor out of r plus 2s squared.
They have an r plus 2s, both of them?
Mm-hmm.
Each one has an r plus 2s. How many r plus 2s's does this guy have?
2.
2. This guy has
3.
So can I take out
2.
2 from each of them? So I'm going to take out an r plus 2s squared. I'm going to take out 2 from each of them, since they both at least have 2 of them in there. Let's leave our leftovers. All my leftovers go in the same thing. You ready? If I took out an r plus 2s squared, I took out both of these, what's left over?
P.
P. I've got a minus
Q.
Q. And then if I took out 2 r plus 2s's,
You have 1 left over.
isn't there still 1 left over? Because there's really 3. See what I did there? I took out 2, but that means there's still 1 left over, right? I wouldn't leave it like that. You shouldn't leave it like that. Hunter, what could you do?
2 times r plus 2s.
Okay?
Negative 2.
Perfect. Let's make it look a little bit more simplified by taking this Q and distributing it through. It's a negative Q, so make sure you bring the negative with it. Left over in this parenthesis, I have a P minus QR minus 2SQ or 2QX, it doesn't matter the order. Are any of those like terms? Can I take something out of all 3 of those? Can I take a Q out of all of those? Because that first guy doesn't have a Q, right? He's just a P. This is as factored as I can get it. It's as factored and broken down as I can possibly get it. Good? Okay. I want you to do 1 more of these, and then we're going to do a few groupings, then we're done. Okay? I do not want you to foil. Foiling is opposite of what I want you to do. So look at E carefully.
Well, can you Google it or no?
That's kind of what we're moving into.
I just do it. Like, say that, say there's 4 terms. Say like P minus 5. And then, say like P minus 5, and then P plus 2 on one side of the equation. And then this on the other side. but I'm gonna go from the business. I'm not sure you're gonna do that. But I'm on the right track. But I just
We'll have to look at it. All right, what do you notice?
P minus 5.
We both have a p minus 5, right? So can I take a p minus 5 out of each of them? If I take out a p minus 5, I have left over here a p plus 2 minus, what do I have left over here?
3p plus 4.
3p plus 4. You see what I did there? Put it in parentheses. Why? Have to distribute the negative. I'm subtracting a 3p, but I'm also subtracting a 4. Where does that make that 4? Negative. You have to make sure that if there's a negative in front, you distribute it to everybody. So if you need to, put it in parentheses so that you don't forget. I should end up having a p minus 5. I should have a p plus 2 minus 3p minus 4. Would you leave your answer like that? No. What can you do?
Just
Combine like terms for me. If you haven't, do it please. One p minus 3p is negative 2p. 2 minus 4 is negative 2. It's not your final answer yet. Look at it.
I've got extra peas.
Extra p's where?
Well, we can just distribute it, right?
No, I don't want you to foil.
Well, okay.
Take out your,
Not very smart, Mike. Can you keep doing that?
Okay, factor, not foiled. But what do you notice? Is there negative 2's in that second parentheses? Isn't there another GCF that I can factor out? Can I go break it down a little bit more? No? Jess, you don't like my joke. All right. Can I take out a negative 2 from both of them? If I take out a negative 2, could I just put it in the front here? If I take out a negative 2, then what's left over? P
plus 1.
plus 1, right? To double check, could I distribute it? What's negative 2 times P?
Negative 2p.
Negative 2P, what's negative 2 times positive 1? Negative 2, so that's why it changes to a plus sign. This is as broken down as possible. There's nothing else I can take out here. There's nothing else I can take out here. It should be as factored as you can possibly get it. Okay? And I took out a negative p, I mean a negative 2, leave me with just the p here. And if I take out a negative 2, then what would I have to multiply it by? To keep it a negative 2. Positive 1. Okay, makes sense? Okay.
How come at the beginning you can't distribute out the p plus 2? Like we did the p minus 5, but how come you can't distribute the p plus 2 with the 3p plus 4?
Here's a subtraction
At the
sign.
very beginning. Yeah, like.
Like
Because
FOIL?
it has, no, because it has a p plus 2.
Yes?
And then you can take a p out of the 3p, and you can take the 2 out of the 4.
They're separate pieces. You have a p plus 2, and you have a separate 3p plus 4. Within this, can I take out a p from both of these guys?
No.
So I can't take a p from here and a p from here because they're two separate things? Is that what you're saying?
Yeah.
And I can't take a 2 from both of these guys in the same parentheses. So I can't take a 2 from this and a 2 from that because they're totally separate
Alright.
pieces. Is that what you mean?
Mhm.
Okay. Okay. All right. Let's do just a few more examples on grouping. When did we say we use grouping? When there's lots of terms. 4 terms probably is what we're going to use most often. We group when there are 4 terms. Okay? If you look at this example, you see there's 4 terms. First thing I want you to do always is step number 1. Put it in order. Is it in order? It's kind of hard to tell, right? There's A's, there's X's, there's AX's. Kind of hard to tell. So let's say it's in order right now. What's my second step? Always. GCF. What can I take out of every single one of these terms? Can I take a 3 out of everybody?
No.
No. Can I take an X out of everybody? Can I take a Y out of everybody?
No.
There is no GCF on this one. Okay? But it doesn't mean I can't factor it. I notice that there are 4 terms. So what I'm going to do is try to group it, it's called. To group. You take your first 2 and your last 2 and you make their own little groups. Okay? So you group the first 2, you group the last 2. And now let's just look at individual groups. If you look at this group, just this group, what do you notice in this group? Can I take out a 3? Let's take out a 3 in that group. If I take out a 3 in that first group, right? Taylor, what's left over? An X. Okay. X minus Y. If I take out a 3. Okay. Now let's look at this group. Let's just look at the second group. What do you notice?
Take out an
Can I take out an A? Can I take out a negative A?
No.
Why?
Because the second A is positive.
But can I force out a negative? If I force out a negative, then what does this sign change to? So that if I were to distribute, it becomes positive. Can I just change the signs? Let's see what happens. If I take out a negative A, then what's left over in this first piece? X. If I take out a negative A, then that changes this sign to negative, and what's left over? Y. You could always double check. You could always double check by doing a quick distribute. What's negative A times X?
Negative AX.
That's good. What's negative times negative?
Positive.
Positive. Isn't that what I want? And now what do you notice?
They have an X minus Y in common.
Don't they both now have an X minus Y? Your leftovers should always match. They should always look exactly the same. If they don't, you did something wrong. That's what grouping is. When you have leftovers, your leftovers should match. So if we didn't take out a negative A, our leftovers would match. Okay, so that's how I knew that we were supposed to take out a negative A, so that my leftovers match. Since they both now have an X minus Y, could I GCF out an X minus Y? They both have an X minus Y, so let's take out an X minus Y. If I take out an X minus Y, let's talk about what's left over. A 3
Minus
and a minus A. Doesn't that look nice and broken down? Factor. That's how you group. Make sense? So what did we do first? We separated it, right? We took the first 2, we took the last 2. Right? Then what did we do with each little group? We took out a GCF out of each group, right? We factored out a GCF. Then we noticed that whatever we had left over they should match. Since they match, what did we do with the matchers? GCF them out, right? Okay, I want you to do B for me, please. I want you to try B for me. I want you to group it. And I want you to follow the steps that we just did.
That's what I was trying to figure out.
Close. You're still in something out here that you have to GCF out something. Okay. You want to GCF that first group? What can you take out of just the first group? 6.
6X.
6. Could I do an X? I can't do an A, but I can do an X, right? So let's take out a 6 and an X. If I take out a 6X, what's left here?
A.
If I took out 6, divided, 12 divided by 6, 2. So when we go through, we're dividing actually is what we're doing by each little thing. And then a B. Did you get that first part? Okay, second part is tricky because my leftovers should match. So my leftovers should be an A plus 2B. And I have to take out something. If I have to take out something, what can I take out so that my leftovers are still an A plus 2B?
One.
Can I GCF out of 1? Let's do it. positive one?
Yeah, positive.
Nice. Let's do it. If I have to take out something, can I take out a 1? It's not going to change anything, and then what's my leftovers going to be?
A plus 2B.
Yeah.
It's being recorded.
Yeah.
For
Not.
quality purposes.
Just voice. They match! I like them. What can we do with them since they match?
Just call it a done deal.
Factor.
No, I'm not done yet.
Factor
Can
in
I
that.
factor them out again? Since I have an A plus 2B in both of them, I'm going to take an A plus 2B out. I'm going to take them out and leave my leftovers. What's left over?
6x plus 1.
6x plus 1. Nice, cute little factors. Right? Good? Okay, Smarty Pants says last one. This is a trick. No, it's not a trick. I lied. Just do it. Do it. Let's see how far you can get. I need you to factor this. Not a trick question. Nick, you grouped it? Why? What happened? Oh man, you can't take anything out. Doesn't mean you can't factor it. Should I switch it up a little bit? Let's do it. Switch it up. What do you want to do? Make something up.
No, that's
Why put the 5 feet?
You putting the 5p with who? Okay. So you want to write it like this? 5p squared minus 10? Okay. You told me to do it, and I'm just following you. Now what? I still got 2 more terms, so who should I put next? P2Q2. Like that? Okay, now what? Okay, let's see. So now could I group it? Can I try grouping now? If I group it now, did Nick help us, or did he make it more complicated? He helped? Can I take something out of my first group now? In that first group, I have a 5p squared minus 10. Also, can I take out of a 5p squared minus 10? Did I take out a 5? All right, let's take out a 5. If I take out a 5, then what do I have left over?
P squared minus 2.
P squared minus 2. So then my leftovers, my other leftovers, should be a p squared minus 2. My other leftovers hopefully match, and I hopefully get a p squared minus 2. So let's look at my second group. And what did you say I could take out, Tim?
Q squared.
Positive q squared you want to take out? Well, I don't know. I'm asking you. What do you want to do?
Let's go negative because the second.
Do I want to keep the second term positive, negative?
Positive, because you want it to be negative.
I want it to be negative, so let's keep it the way it is. So I don't want to change my signs. Let's take out a q squared, positive. If I take out a q squared, what's left over? Do they match? Since they match, what can we do? No!
Or
Factor.
Factor.
Oh, I thought you were saying FOIL that. Scared me. Let's take them out. I got a p squared minus 2 that I took out from each one. What's left over?
5 plus Q squared.
5 plus q squared. Q factors? Okay, is it cute? That was me. That was pretty cute. Okay, let's step number 1. In order, step number 2.
Yeah.
GCF. Then we're gonna do grouping if we need to. How do I know when we do grouping?
4 terms.
4 terms. You group the first 2, you group the second 2, you see if there's a GCF. If there's not a GCF, what do we have to do on this last one? You have to write them out differently, right? And then try to group them again. Okay? All right. Here's your homework. See how much we can do. I'll race you.
No, thank you.
Sorry. 31. Yeah. So I think we're out of here at 31. So you've got some time. I'd like to see if we can finish before you leave so you don't have any homework over your homecoming weekend. Are you shocked? No.
I can see you being that chef.
Oh wait, we're still recording. Hold on.